Good morning students. Today we will discuss about intrinsic and extrinsic semiconductors. Before going to intrinsic and extrinsic semiconductors, we will have the brief introduction about semiconductors. So what are semiconductors? Semiconductors means these are the materials which are having properties in between conductors and insulators. They have the properties in between conductors and insulators. So at T is equal to 0 Kelvin, if I don't give temperature, these semiconductors behave as insulators. If we give temperature, what happens? The semiconductors conducts, it starts conducting. So they behave as conductors. Now in semiconductors, as temperature increases, its conductivity also increases. Now what are the known examples of semiconductors? So the known examples of semiconductors are silicon and germanium. Here silicon and germanium are tetravalent, means they have 4 valency electrons. They have 4 valency electrons and they have diamond structure. So silicon and germanium have 4 valency electrons and they have diamond structure. Now the conductivity in semiconductors. See here, what are the charge carriers? Charge carriers in semiconductors are both electrons and holes. In semiconductors, conduction is due to both electrons and holes. Next, the process of adding impurities to the semiconductors is called as doping. Because of its doping, semiconductor conductivity increases. So, why we need to discuss about semiconductors means semiconductors will be having many applications in the electronic fields. So, maximum devices will be prepared from semiconductors because of their characteristics. Next, see here how many types of semiconductors are there. Here there are 2 types of semiconductors. One is intrinsic semiconductor and another one is extrinsic semiconductor. So semiconductors are divided into 2 types. One is intrinsic semiconductors and another one is extrinsic semiconductors. Intrinsic semiconductors are pure form of semiconductors. Means here no doping of impurities. Pure form of semiconductors, we call it as intrinsic semiconductors. Extrinsic semiconductors means impure form or doped form of impurities. Here in intrinsic semiconductor, if I add impurities to intrinsic semiconductor, then it becomes extrinsic semiconductor. So depending on the doped material, again these extrinsic semiconductors are divided into 2 types. They are N-type and P-type. Okay. So now we will see about intrinsic semiconductors and extrinsic semiconductors. In this, first we will discuss about intrinsic semiconductor. So intrinsic semiconductor or the bond and band structure of intrinsic semiconductor. We will have brief about intrinsic semiconductor. Now, what are intrinsic semiconductors? As we have discussed before, intrinsic semiconductors are pure form of semiconductors. These are the pure semiconductors. What are the examples for semiconductors? Silicon and germanium. Here, if I consider silicon, so how many valency electrons does it have? It has 4 valency electrons. Now, silicon is having 4 valency electrons. So, in order to attain stability, it should have octet configuration, means 8 electrons in the outermost shell. So, it is having only 4. How many more electrons it requires? In order to get stability, already it is having 4 valency electrons. How many valency electrons it requires more to attain stability? So it requires 4 other electrons. 4 more electrons are required to get stability. So what happens is, one silicon is having 4 valency electrons, another silicon is having 4 valency electrons. So if they go for sharing, if they share, silicon and silicon share atoms, share electrons, they attain stable configuration. So they form sharing of electrons. So which bond is formed? Covalent bond. So one silicon atom forms covalent bond with other silicon atoms. So this we call it as bond structure. Now we can see bond structure in the diagram. Okay. Now, so these are the silicon atoms. These are the silicon atoms. Next, so one silicon is having 4 valency electrons. Next, so it is sharing these 4 electrons with other silicon atoms. Other silicon atoms also having 4 valency electrons. So it is becoming stable by attaining 8 valency electrons. So see here, this is one silicon atom sharing electrons with each other. Okay. Now, so what are these? See here, these are silicon atoms. These are silicon atoms. Here, these are silicon atoms or tetravalent atoms which are having 4 valency electrons. Now, what are these? These are covalent bonds. They are sharing their electrons and they are forming covalent bonds. Now, see here, when we give energy, what happens? So, when we supply energy, what happens is, here the covalent bonds will be broken. So, see here, this electron can tear this covalent bond and it can come out of the bond. See here, this electron, here electron tears this covalent bond, means these covalent bonds will be broken and electron comes out of the bond, leaving vacant space. This vacant space we call it as hole. This vacant space we call it as hole. The electron which is coming out of the bond, we call it as conduction electron, which is responsible for conduction. This we can call it as free electron or conduction electron. And this vacant space we call it as valency hole. So this conduction electron carries negative charge and this valency hole carries positive charge. Hole is having positive charge and electron is having negative charge. See here, if one electron is coming out, how many holes are formed? One hole is formed. So if 2 electrons comes out, 2 holes will be formed. If n electrons comes out, n holes will be formed. Means we can say that number of conduction electrons is equal to number of holes. Means here majority charge carriers are both electrons and holes. Okay. So whatever we have explained, that is given as notes. See here, the electrons participating in covalent bond are called as valency electrons. Means the electrons which are participating in the covalent bond, these are called as valency electrons. These are called as valency electrons. Next, see here, if some energy is supplied, then covalent bond breaks and electrons comes out and move freely, creating vacant site, which is called as hole. So when electron is coming out, what happens? It is leaving vacant space, which we call it as hole. See here, the holes are positive charge carriers. Here charge carriers are both electrons and holes, because number of electrons is equal to number of holes. So this is about bond structure. So this is about bond structure. So which bond it has? Covalent bond. Next, so if I go for band structure, so this is of band structure. So if I see the band structure, so see here, this is the valency band and this is the conduction band. Now EV, here EV is represented as energy level at the top of the valency band. This is the energy level at the top of the valency band. EC is the energy level at the bottom of the conduction band. EV is the top of the valency band and EC is the bottom of the conduction band. So the gap between valency band and conduction band is called as energy gap. The gap between valency band and conduction band is called as energy gap or forbidden energy gap. Okay. Now, where does valency electron lies? Valency electrons lies in valency band. Valency electrons lies in valency band. So, if I see at T is equal to 0 Kelvin, if I don't give any temperature, valency band is completely filled with electrons. Completely filled with valency electrons. So, here at T is equal to 0 Kelvin, valency band is completely filled with valency electrons. Next, conduction band is completely empty. Conduction band is completely empty. There is no electron here. Okay. At T greater than 0 Kelvin means when you give temperature. When you give temperature, what happens? The electron jumps from valency band to conduction band. These electrons jumps from valency band to conduction band, leaving vacant spaces. These we call it as holes, and these we call it as conduction electrons. These we call it as conduction electrons. So the electrons present in the conduction band, are responsible for conduction, and holes present in the valency band are responsible for conduction. So which holes are responsible for conduction? The holes present in valency band. Which electrons are responsible for conduction? The electrons present in conduction band. Okay. Now, so see here, topmost occupied level, Fermi level is referred as topmost occupied level at absolute zero temperature. So this Fermi level, topmost occupied level lies at the middle of, so see here, this topmost occupied level lies at the middle of valency band and conduction band. So where does Fermi level lies? It lies at the middle of valency band and conduction band. Now how to calculate energy gap? Eg is equal to Ec minus Ev. Fermi level, it is in between valency band and conduction band. So Ec plus Ev by 2. So this is about band structure of intrinsic semiconductors. So extrinsic semiconductors we can see in the next class.